Hi, everyone. So let's talk a little bit about this worksheet where a lot of the things from the test tomorrow are going to be from this worksheet. So it's the same process, right? So let's take a look at a couple of these problems that I had worked out. And this key is on eClass as well, but I wanted to show you how it's going on here. So the original problem was the square root of 23 minus 2m equals square root of m minus 4. First, we have to square both sides, right? When we square both sides, it gets rid of the radical signs. And we're left with this, right? 23 minus 2m equals m minus 4. So we're just going to solve this multi-step equation, add 2m to both sides, and then we will add 4 to both sides, and we'll solve it. And we'll get 9. Now, we want to make sure that we check these things. So what I did was I took the m is 9 and plugged it back into both of the m's. And I did that here. So you can see here that I have the 9 here and the 9 there. So when I solve this or simplify it, I get the square root of 5 equals the square root of 5, which means that does work, which means there's nothing extraneous because it works, right? So let's move over to another problem. So this one's a little bit simpler, right? When I square both sides here, I get a quadratic. Now, this process right here, right, is if I add b and subtract 12 from both sides, I'm going to get this quadratic function. And when I have the quadratic, I have to use the area model to solve it. Now, long story short, when I get the area model done, I'm going to get values of 3 and negative 4. Well, the problem is that usually when I have two answers, one of them probably will not work. So what I did was the 3 I plugged back in, and that does work. But when I plug a negative 4 in, it does not work, because what happens is I get negative 4 on one side and 4 on the other. So that's extraneous. So you would say that negative 4 would be the extraneous solution. Okay. Moving forward, cube root both sides, or cube both sides. I'm going to get a nasty fraction, but that's okay. It does work. Here, same thing. Now, this one's a little tricky. So I cannot raise both sides to the third power yet because there's a 7 in front. So I have to divide both sides by 7 first. And then I'm able to cube each side, all right? So just be really careful when there's something in the front here, okay? You're gonna square both sides there. Square both sides there. Again, I'm gonna have a quadratic. Now this one's weird because I got neither works, right? And that's not good, right? So when neither of these things work, that's no good. That's really rare, actually. So don't worry about that so much. Okay. Nothing crazy there. Again, neither work here. It's like we just picked ones that don't work. Okay. No, okay, great. So here, when I square this side, I get this. You can't just distribute the square to both of these things. You have to area model this. Now, I did not area model this here because I wanted to save some space. But when you area model it, you're going to get this quadratic. Same as before up top, you're going to subtract 4x and add 11 on both sides. And then after it's all said and done, this here turns into this, okay? Now you're going to area model that, and we get two solutions. Now this one both did work, okay? I want to skip 11 and 12. We haven't, actually, I want to skip 10 through 12. We haven't talked about that in class, so I want to skip those for now. Graphing functions, we've done this a million times, right? We're trying to find values that are friendly. So remember, for a cube, right, because this is a perfect cube, our perfect cube numbers are -8, -1, 0, right? And then 1 and 8, okay? So you gotta be careful of those values there. And then for perfect squares, and we know it's a square because there's no thing in the middle there, we can do 0, 1, 2, oop. I'm getting carried away with this cool pen. 0, 1, 4, 9, and 16, right? We don't want to go any further than that. Okay. Characteristics. End behavior is the big one. Positive and negative will skip when it doesn't actually touch the axis. So when it touches the axis, we're in good shape. Okay, I didn't do these two because I didn't want to. And then transformations, right? So pretty self-explanatory. Vertical stretch of 4, y-axis reflection, left 3, up 6. Really nothing surprising there, okay? All right, so hopefully I'll see you tomorrow. If not, you're gonna do great on the test. Go ahead and send me any questions you have on our mind. I'll do my best to answer them, okay? Bye.